Today is going to be another Algebra 1 review day. We're going to be reviewing how to factor quadratics. Yes, this is something you learned how to do in Algebra 1, but there's a good chance that you've forgotten how. Or maybe you were just never good at it in the first place. Or maybe your teacher taught it in some kind of weird, guess and check method or something like that. I don't know. The point is, I find that before I can go to the next section of the Algebra 2 textbook, I have to review these Algebra 1 skills and pretend you've never learned how to do it before. So today we are going to, quote-unquote, learn how to factor a quadratic. Grade in. If you don't want to factor my way, you don't have to. It's not a big deal. It doesn't really bother me. It's just that I think it's the best way of factoring. I really like it. So it'll be the way that I use. Cool? Cool. It's called the Lizzie method. I think it's called the Lizzie method because of the person who came up with it, I guess. I don't want to say discovered it, but I guess the person who came up with it. It's taught, it's the way that they teach how to factor over in Britain. It's taught in Michigan schools and things like that. It's a great method. I love it. And it'll be used a lot for the rest of your high school career. For any other math class you take, other than maybe probability and statistics, you will have to be able to factor. And you might not be surprised to find out that factoring is a skill that students lack all the way up through AP Calculus, and even our HL mathematics students, math teachers find, holy cow, these kids can't factor. If you master the Lizzie method, though, you won't be one of those people. So I have a 7-step process. Do you need to memorize the process in word format? No. I'm going to read through it real quick, but then I'm going to use the 7-step process on an actual quadratic, which you see down there. It says x squared minus 11x plus 10. We're going to use it to factor. Step 0. Notice it says step 0. Why step 0? Well, because it doesn't always happen, but it is something you should always start with. You should always start by looking for a GCF, a greatest common factor. Is there something that every single term has in common, other than the number 1? We don't really care about the number 1 again. But do they all have something in common? Well, if they do, that's the GCF, and you should factor it out to the front. And factoring is a kind of division. Now, once that is out of the way, once step 0 is out of the way, because it may or may not occur, step 1, you're going to make a t-table. That t-table is going to have A, C in it. In mathematics, when we put 2 letters next to each other, that means multiply them. So we're going to figure out what A times C equals. And you're writing an awful lot back there. You know this is in the note packet, right? Yeah, you don't have to write all this. I'm trying to save you trouble. Anyway, A times C. And we're also going to have our B value in that t-table. All right. We're going to find the 2 numbers that multiply to A times C and also add to that B value. We're going to write 2 sets of parentheses, and they will both have an X in the front. Yes, sir. Yeah. Didn't write you a pass for that. All right. These are epic YouTube notes with pass writing in them. Let me go ahead and pause the video while I do that. So where was I? Okay. So we open our 2 sets of parentheses. They both have an X in the front. Now the 2 numbers that you found, and don't worry, we're going to do all this. I'm going to demonstrate all this with numbers. But the 2 numbers that you found in step 2, those are going to go right here and right here along with the symbol in front of them. So if it was a positive number, there'll be a plus. If it was a negative number, there'll be a minus, yada, yada, yada. But here's what makes this the Lizzie method, right here. That number will be written on top of a fraction bar. So there will be a fraction in both of these sets of parentheses. The numbers you found will go on top of the fraction bar. So what goes on the bottom of the fraction bar? The A value. That is what makes it the Lizzie method. There will be an A value, which is the number at the beginning of the quadratic, on the bottom of that fraction. You reduce your fractions, and if there's still a denominator once that fraction is reduced, move it to the front of the x, and you're finished. It looks like a long process. It's really not. You know what the hardest part is going to be? The t-table. You know why? Multiplication skills. Students lack them. We need to get good at our multiplication skills. And once we are good with multiplication, we will be good at factoring. Again, do you have to use the Lizzie method? No. If you're more comfortable with some other method, go for it. I don't care. I just want to make sure that you have a method that you can be successful with. So let's go ahead and factor this one according to the Lizzie method. But first I want to do our screen sharing. Oh, uh-oh. Am I still screen sharing? I just clicked on something I've never clicked on before. Oh, it moved to the bottom. Okay. Okay, let's see. I'm trying to, there we go. We'll disable the annotation. Not necessary for today. Okay. Factor this quadratic. Let's talk about what a, b, and c are in case you don't remember from standard form. A is the number in front of x squared. B is the number in front of x, negative 11. And c is the number that has no x. We all right with those ideas? That's from standard form from last chapter. Let me look at these things. X squared, negative 11x, 10. Yeah, they don't have anything in common. Other than the number 1, they have nothing in common, so there is no GCF for us to worry about this time. Let's make ourselves a t-table then. That t-table is going to have a times c, and it's going to have b. A times c, well, that's 1 times 10, so that's 10. And the b value is negative 11. We are looking for the two numbers that will multiply to 10 and will add to negative 11. Now, until you get good at this, maybe you just want to list out all the ways you can think of to multiply two numbers to get a 10. Until you're good at it, maybe you need to do that. I don't want you to have to do that, but for now, that's what I'll demonstrate. So I think to myself, let me list all the ways that I know I could multiply two numbers to get to 10. I could do 1 times 10, but that's going to add to positive 11. That's not what I needed. I could do 2 times 5. That's going to add to positive 7. It's not what I needed. And I'm thinking, well, crud. When I added my numbers for both of those options, I got a positive. How am I going to add and get a negative, but multiply to get a positive? What's that, Catherine? No, say it.
I was going to say multiply negative 1 and negative 10.
Ah, they're both negative. That's the way. If they're both negative, you would multiply to get a positive number, but you would add to get a negative number. So our other options would be negative 1, negative 10, and negative 2, negative 5. Those are all the ways to multiply to get to positive 10. These add to negative 11. These, I'm having a frog in my throat problem today. Like I said, we were hunting for the ones that added to negative 11. So this is what we wanted, was this result. So these two numbers are the numbers that will be inside our parentheses. So we write our two sets of parentheses, we throw an x in the front of both of them, and now we write our two numbers on top of a fraction bar. Those two numbers were negative 1 and negative 10. The bottom of the fraction bar is a. A is 1. It's this value. You're supposed to reduce your fractions now. 1 over 1 is 1. 10 over 1 is 10. It's factored. Mr. M, I don't really see the purpose of the over A. It didn't do anything. And I go, well, this time it didn't. Sometimes it will. And this is one of those things where I say, like, you know, it's like parentheses. If you use them every time, you'll never accidentally miss one of the times where you should have used them. So if you divide by A, every single time, you'll never miss a time where it was actually necessary. This is one of those times where it wasn't necessary because it didn't change anything. Okay, didn't change anything, fine. We're finished though. X minus 1 times x minus 10, that would give us x squared minus 11x plus 10. If you FOILed it. You guys remember how to FOIL? Well, if you FOILed it out, you would get back to the original quadratic. Before we go on to more technical examples, is there any questions that I can answer about the Lizzie method? No? All right, well, fine. Then we will just go on to, like I said, more technical examples. This factor the quadratics, we'll approach them one at a time. I'm sorry? I'm sorry? Yeah, I just wanted you to be able to take the quadratic apart. Could you take it from standard form back to intercept form? Because that's what you just did. Remember, standard form is ax squared plus bx plus c, and intercept form is two sets of parentheses being multiplied. So could you take it from standard to intercept? And we just did. So these are both in standard form, and our goal here is to get them into intercept form. That means factor them. Step 0 is always the same. Look for a GCF. Do they have something that they can all be divided by? Yes, they do. There's a GCF. They can all be divided by, ooh, that's ugly. They can all, okay, hold on, I can try again. GCF. They can all be divided by the number 5. So what you do is you divide everything by 5, but you don't just throw the 5 away. The 5 is part of the polynomial, so it goes to the front. You undistribute this 5. I just undistributed a 5. Remember, the next test is no calculator. You must be able to multiply and divide. So the thing inside parentheses, that is where we identify our A, our B, and our C. So A is 1, B is -6, C is 8. The t-table part of this process should be the hardest part. That doesn't mean it's difficult. It's just the part that I think should be the most challenging for most students. 8 times C is 1 times 8. Your B value is -6. If you need to list out all the ways to multiply to 8, and then just find the one that adds to -6, go for it. I'd like to not. I'd like to just big brain my way there and think, I need to multiply two numbers and get a positive result. That means I'm either dealing with two positives or two negatives. When I add these two numbers, I have to get a negative value. So what does that tell you? What kind of numbers are you multiplying? Two negatives. So we're looking for two negative numbers. They multiply to +8. They add to -6. What are those two numbers? 4 and 2, but they're both negative. Yeah. So -2, -4, and it doesn't matter the order that you say them in. So yay, that worked out perfectly. Yeah, -2 times -4 is +8, and yeah, those add to -6. Fantastic. You write your two sets of parentheses. But you know what you don't forget? Because if you do your answers wrong, that 5. Extremely common student mistake is to lose the 5. Don't lose your GCFs. They're not gone. They stick around. So please, hold on to them. Put an X in the front. I'm going to go ahead and put a fraction bar. So X is in fraction bars. The numbers we found were -2 and -4. The A value that we're working with is 1. So when you reduce your fractions, you have x minus 2. So once again, dividing by a did nothing. And x minus 4. So yeah, okay, dividing by a did nothing again. That's okay. Was it hard to throw that step in? No. And because I'm going to throw it in every single time, I will be darn sure that I don't forget to do it when it was required. Because on the next one, if you forget to divide by a, your answer is wrong. But before we get to the next one, is there anything I can help anybody with on this question? Lewis, almost had a question? What are you thinking? Mm-hmm. Well, the table is always going to be what multiplies to a times c and what adds to b. So this number here is going to be found by you multiplying a and c every single time. So you're always looking for the two numbers that multiply to AC, whatever AC equals, and those two numbers will need to add to B every single time. Like I said, the table ends up being the hardest part. Alrighty, let's begin this one. Let's see, step 0 is look for a GCF, and you know what? There isn't one this time, and that's okay. That's why it's step 0. It's not always going to happen. I will go ahead and identify, I'm out of left or right space, so I'm going to go ahead and identify my ABC over here. A is the number in front of x squared, 6. B is the number in front of x, -1. And C is the number with no x, -2. And like I said, I'm kind of out of space here, so let's see if I can get fancy. Give myself some more space. Yeah, look, more space. All right. Our t-table. Looking for the two numbers that multiply to a times c. Those two numbers will need to add to our b value. A times c is 6 times -2, -12. Holy cow. The lag is real today. There we go. The right slower. And b is -1. Try to incorporate Graydon's little purple line he drew. So we're trying to figure out which two numbers multiply to -12 and then add to -1. Well, look, there's only one way to multiply two numbers to get a negative result. That's if one number is positive and one number is negative. So we're going to be multiplying a positive number and a negative number to get to -12. I need those two numbers, though, to add to -1. That means those two numbers are pretty darn close to each other, quote unquote. So what would my suspects be? I'm sorry? I'm trying to get to 12. So what two numbers would multiply to give me -12? What's that, 3 and 4? Yeah. So we have two options. We could do -3, +4, because remember I said one has to be negative, or we could do 3, -4. We need the one that adds to -1. That's this one. Those are the two we needed, 3 and -4. You couldn't instantly see that it was 3 and -4? Fine. You could do 1 and -12, -1, +12. 2 and -6, -2, +6. And then list those. You're welcome to list them all out and just see which one works. If you need to, do it. It's not a big deal. There is no shame in that game as long as you're getting right answers. You're going to write your two sets of parentheses now. You put an x in the front of both. Put a fraction bar in both. Now your two numbers are going to go on top of those fractions. The first one's a +3. So +3. The next one's a -4. So -4. And then under the fraction, you put your a value. A is 6. And this time it makes a huge difference. This is the first time that we're going to have to do the reduce the fraction step. I still feel kind of crowded, so I'm actually going to write a little bit lower just so I have more space because I write kind of large. When I reduce these fractions, what I get is x plus, let's see, 3 over 6. I can divide both those by 3, 1/2. And x minus or over 6, this can both be divided by 2, 2/3. The very last step is anywhere there's still a denominator, like anywhere there's still a fraction, you take the bottom of that fraction and you stick it in front of x. So what you end up with is 2x plus 1 times 3x minus 2. Now that standard form quadratic is written in intercept form. When you become fast with this method, it is the best. It is the best method. It's not the only method, it's just the best. It's reliable, you know. And as long as you're doing the whole divide by a thing properly, you're going to be set. So that one actually involved the divide by a, reduce fractions, move denominators. Can I answer any questions about it? Please, if they're out there, let me hear them. By the way, if you ever want to watch more videos on how this is done, you can go to YouTube and type in Lizzie method and videos will come up. I'm not the only one using it. No? Still silence? Oh my goodness. All right, well. Then we go to the last slide. Step 0. Look for a GCF. Is there something I can divide all of these by? It's 3. I can divide them all by 3. So we have a GCF of 3. You undistribute the 3. 5x squared minus 9x minus 2. Boom. Now that you have undistributed, now that you've factored out your GCF, this is going to be where you identify your A, B, and your C. A is 5, B is negative 9, C is negative 2. You know, to save myself some vertical space, I'm going to build the t-table directly below this because I noticed on the last slide I was running out of, not vertical space, horizontal space. So I'm going to be looking for the two numbers that multiply to A times C. And A times C is 5 times negative 2, or negative 10. Okay, I'm multiplying two numbers to get to a negative 10. I already know that means I'm multiplying a positive and a negative. And I need these two numbers to add to my B value, which is negative 9. So I need the two numbers that will multiply to negative 10 that will add to negative 9. Positive 1 and negative 10. Yep. And order of the numbers doesn't matter. I just usually say the small one first. But yeah, perfect. 1 and negative 10. Those multiply to negative 10, and yes, they do add to negative 9. Boom, baby. There it is. Please don't make the common student mistake. Please don't lose your GCF. That 3 is part of the answer. Now your two parentheses, x's and fraction bars. The two numbers you found go on top of the fraction bar, and their symbol goes in between. Well, 1 is positive, and the 10 was negative, so put a minus sign there. And you put them both over the A value. Your A value was 5. Reduce any fraction that can reduce. Okay, well, 1/5 doesn't reduce. I'm just going to write it as 1/5 for now. But 10 over 5, that does reduce. That's just 10 divided by 5, which is 2. The very last step of the Lizzie method was, yo, if you still have a fraction somewhere, take its denominator, stick it in front of x, and you're finished. So we're going to take this 5, we're going to throw it in front of this x, and we are finito. 3 times 5x plus 1 times x minus 2. We took a quadratic out of standard form and brought it into intercept form using the Lizzie method. Yes, sir. 3 is the GCF. It was this 3 right here. Since it was on the front there, it's always going to be on the front. It's part of the answer. If you lose that 3 at the bottom, when you FOIL it out, you will not get 15x squared minus 27x minus 6. If you lose the 3 and you FOIL it out, you get 5x squared minus 9x minus 2. I just don't want you to forget it. Because if you forget it, you're only going to get like 3/4 credit on the test. I don't want that. I want you to get full credit. What do you think? Scary hard? Did any of your teachers show the Lizzie method in Algebra 1, or did they do something different? I just want to know if anybody used the Lizzie method. Yeah, I don't. The Algebra 1 teachers, depending on who you had, some of them use a method called slip and slide, which is pretty similar to this one, honestly. Some of them use something called the AC method, which uses the same t-table, but then does a little bit more work after the t-table. Slip and slide is well, it's got that X, right? I don't know the method. I just know what it's called. I've seen it, but I've never bothered learning it. If you are good at that and you don't want to use this one, then use it. Okay? This is just another tool in the toolbox. It's up to you to choose the tool. I just want you all to know that. I'm never going to say use the Lizzie method. I'm just going to say you'll factor the quadratic. Pick a method. You know, are you using a guess and check method? Fine, whatever, as long as you're good at it. Are you using slip and slide? Fine, whatever, be good at it. AC method? Fine, whatever, I don't care. Lizzie method? Okay, great. You know, it doesn't matter. Get answers right without cheating. That's all I care about. That's all I care about. And the last one is unique. Anybody see what makes this one different from all the other ones? It's different in one very specific way. The negative on the front. That's what made this one different. Rule time, I'm not going to write it, but you might want to. Anytime the front number is negative, there is a negative GCF. Anytime the front number is negative, there is a negative GCF. Anytime there is a negative on the front, there is a negative GCF, even if that GCF is -1. You don't want to try to use any factoring methods with a negative A value. It just makes life difficult, and more than likely you will get your answers wrong when you're trying to use factoring as a solving method. So I would say the moment you see a negative number on the front, you know you're going to undistribute a negative number, even if that number is just -1, just to make sure the front number is positive. So I'm looking at this one, and you know what? 8, 28, and 16, they can all be divided by the same number, 4. But since the front number is negative, I'm going to say the GCF is -4. I'm going to undistribute a -4. And I have to make sure that that -4 is on my answer at the very end. Because if I forget the -4, my answer is wrong. I don't want that to happen to you guys. Let's pull a -4 to the front. Basically, you're dividing everything by -4 now. Remember, when you divide a negative by a negative, you get a positive. And that was the whole point. We were trying to make sure that this front thing was positive. 28 divided by -4 is -7. And 16 divided by -4 is -4. Now that you have pulled your GCF, you can identify your A, B, and your C. This is where you want to do that. A is 2. B is -7. And C is -4. Crud. There we go. Keep missing. Time for the t-table. Looking for two numbers that multiply to A times C. This time our AC is 2 times -4, which is -8. I need those two numbers to add up to my B value. This B value is -7. Once again, I'm multiplying two numbers to get a negative result. That's only possible one way. I must be multiplying one positive number and one negative number. So I'd be looking for the one way to multiply to -8 and add to -7. You can't instantly see it, fine. List them all out. That's okay. I don't mind. I just want you to be able to get the answers right. But I would like for you to be able to see that it's, yeah, -8 and +1. I'm going to do 1 and +1 and -8 just because I like to see the small number first. But that's just a habit of mine. Yeah, 1 times -8 is -8, and when you add them, yeah, you get -7. So, yay, that was the one we were looking for. The very first thing I'm going to write is my GCF. I want to make sure that I don't lose that thing. So there's my negative GCF. Now my two sets of parentheses. Those parentheses have an x and a fraction bar, an x and a fraction bar. The numbers we found, +1, -8, we put them over our a value. This time our a value was 2. And you reduce any fraction that will reduce. Okay, well, 1/2 isn't going to reduce. It's already fully reduced. But, oops, missed a parenthesis. But 8 divided by 2 is 4. And then anything that still has a denominator, move that denominator in front of the x, and you are finished factoring. You have written a quadratic, that was once in standard form and is now in intercept form. Come on, panel, catch up with me. I hit undo twice. We're just waiting here. There we go. All right. -4, 2x plus 1, x minus 4. And remember, the order of these parentheses does not matter. If my calculations are correct, you still have a whole half sheet of blank paper, don't you? Cool. I'm going to put an example on the board, and we're going to see if you can handle it on your own. But before I do, I want to know, can I help anybody? Are there any questions I can answer? I mean, I know I did the process over and over and over again, and I asked the same question every single time, but for real, I mean, even the tiniest question. Yeah, what's up? Yes. So AC being next to each other means multiply them. Sometimes those are the two numbers you were looking for. But most of the time they're not. But sometimes they are. You see, this time I multiplied 2 and -4. I ended up needing 1 and -8. But, yeah. Yes? The Lizzie method is always going to require a fraction bar. Now, what we did in the beginning steps was if our a value was 1, then on the bottom of your fraction, you just had a 1. And then it didn't do anything and you just got rid of it. So what I'm asking you to do is always do the division if you're going to use this method. That way you don't accidentally forget to do it when it was necessary. It's like using parentheses. When I was telling you to do the parentheses, I'm like, just be in the habit of always using them. If you always use them, you won't miss a time when you should have used them. It's the same idea. So if you're always doing the over A, over A, over A every single time, you'll get it right every single time. Yes, Kevin? The GCF, what you have to do is you have to look at the 3 terms, or 2 terms if there's only 2 of them. You have to look at the terms and you have to ask yourself, is there something I could divide them all by? That's all you're doing. And if the answer is yes, then you need to. You pull it to the front. How are we feeling? Feeling good about that? Okay. I am going to make up an example real quick and write it on the next slide and then have you guys solve it as well. Or have you guys solve it to test your skills. Hold on one moment. I'm going to pause the video while I make it up. All right. Now that I'm confident I have a good working example, we'll go. You okay back there? We'll go to the next slide and I'll write up a practice example for you to test your skills. If you would please factor this quadratic. -18x squared minus 21x plus 9. Once again, I'll pause the video while you guys work on it. Let me go ahead and get it done before the bell rings. The period ends at 21 today, so in less than a minute. I noticed the GCF was -3. leaves behind a 6x squared minus 7x plus 3. A is 6, B is negative 7, and C is 3. Your A times C is 18. Your B value is negative 7. What went wrong? There it is, sorry, positive 7. Boink. Yeah, I missed up 2 symbols because I'm in a rush. Trying to beat the bell. This should have been a negative 3. Ah, shuck, shoot, darn. Well, here, I'll write the answer for you at least. You should have gotten negative 3. Come on, pin. Negative 3, 2x plus 3, 3x minus 1. That's what you should have gotten. Dumb old bell.